I want us to talk about natural logarithms. The logarithmic function with base e is called the natural logarithmic function. I spoke with you in a previous video about e. E can be found on your calculator. Okay? So, if you're asked to graph f of x equals to ln of x, some textbooks say ln of x, some textbooks and teachers say ln of x. Okay? Now, anytime that you see f of x, that's really y equals to ln of x. So if you're asked to graph this, just like you were with the logs, if you have y equals to log, a logarithmic function, to graph a logarithmic function, we will first change it to exponential. Well, the question here is, what is my base? Well, ln has an understood base of e. Okay? So if we were to convert this to exponential, converting it to exponential, just like I did before to graph, converting it to exponential, e would be my base, y would be the exponent, equals to x. Now, I'm not going to graph this. I'm just going to talk with you about it. We would use a table, and we would pick our y's and plug them in one at a time and get back our x's. And we would use this to graph f of x equals to ln of x. Now, you might have something like this. F of x equals to ln of x minus 2. Well, to graph this transformation, you would take your original graph, look at the notation. This one's ln of x, this one's ln of x minus 2. Wouldn't this one be a vertical shift down 2? So just like your logarithmic equations, or your logarithmic functions, functions that you're graphing, you will look at the original and then compare to your new graph or your new problem what has been added. So this one had added minus 2 to the back, therefore this would be a vertical shift down 2. So just remember that ln has base e if you don't see one. Now, I also want to make sure that you understand that if you are graphing y equals log x, if you don't see a base of log, your base is an understood 10. Okay? Anytime you don't see a base with the word log, it is base 10. So if I was to change this to exponential, it would be 10 to the exponent y equals to x. So again, I would use my table. I would pick my y's just like I did in the previous video and find my x's. So I'm just wanting to make sure that you understand that ln has base e. To graph a ln or a log, we convert it to exponential and pick the y's. And log has an understood base 10 if you don't see one. Convert it to exponential and then pick your y's. Now, I want us to next talk about evaluating lns. Okay? We've talked previously about evaluating logs. Okay? So let's evaluate the ln's. Okay. To evaluate, you're looking for the exponent. Okay? So understand that ln has an understood base e. So what you're thinking about is e raised to what exponent gives you e to the 6th? Well, again, sometimes these problems are so easy, they're hard. Well, what do I need to put here so that the left side equals the right side? Wouldn't it be 6? So if you evaluated this problem, your answer would be 6. This whole problem equals to 6. Because it has base e, understood, e raised to what exponent gives you e to the 6. So your answer is 6. All right, let's look at this one. Evaluating this problem, this has a base e, understood base e for ln. So you're looking at e, this e raised to what power gives you 1 divided by e to the 7th? Well, it wouldn't be a positive exponent because that would never move e to the power down to the bottom. It would need to be negative anytime you're given a base and you need to raise it to a power and make it become a fraction. In other words, you're making the e go down to the denominator, therefore you need to put a negative. My exponent needs to be negative 7 because e to the negative 7 would mean that e to the negative 7 comes down to the denominator because of the negative exponent, leaving only the 1 in the numerator. So the exponent here in this problem would be negative 7. E to the negative 7 equals to 1 divided by e to the 7th. Now I want to work one more with you. Log. Say I gave you log of 100 equals to what? Okay? Now, if you don't see a base on log, it is understood to be 10. So you're thinking, change it to exponential. 10 raised to what power is going to give you 100? Well, 10 to the first is 10. What's 10 squared? 10 times 10 is what? 100. So if I was evaluating this log here, it would be 2 because 10 squared is 100.